This is episode 3 of my free CCNA course. And a huge shout out to Boson Software, the official sponsor of this CCNA course. They are the reason this can be made available for free, so I highly encourage you to go check them out. They have the absolute best CCNA, CCNP, labs, and practice exams. Okay, I need you to stop and think about this for a second. I want you to appreciate the fact that this device right here, a Raspberry Pi, can connect to a network and talk to my iPhone. They can share photos, they can email each other, do whatever. It might not seem amazing because this kind of stuff is just commonplace, it's what we're used to every day. But once upon a time, a long time ago in a galaxy far, far away, if you had a device that was made by two different companies, they could not talk. This is where things like the TCP IP model or the OSI model, networking models, save the day, like for real. But how? Well, let's take a look back in history real quick. A long time ago, I'm talking Stone Ages, 1960s. Some smart guys are sitting around with their computers and they were thinking, man, gee willikers, I really wish they could talk to each other. I wish I could share a file with you, friend. But they couldn't. But then they hatched an idea. They came up with something. They go, what if we can network these things together? What if we can connect our computers together and we could send data across? They did that. 1969, the birth of the first network. They called this, ARPANET. The US DoD, or the Department of Defense, came up with it. And it was revolutionary. Like, people could actually have their computers talk to each other, which I know sounds like not a big deal right now, but back then, that was it. That was the new thing. But hold on, here's the problem though. This was more of an idea. Like, they legit did it. Like, here's the first network diagram I think there ever was. Check this out. Look at that thing. I have no idea what's happening. And when I say idea, they were like, yeah, this is a cool thing we can do. They actually invented what's called packet switching, which is what we do today. But what they didn't have yet is the how. How do we make these computers talk to each other? You see, that part wasn't quite ironed out. But the idea spread like wildfire. So companies like IBM, they were like, heck yeah, we have computers. Let's design our own network. And they did. It was proprietary, meaning it only worked with their stuff, which is fine if you have an IBM computer, but there wasn't just IBM. There were other companies, and guess what these other companies did? They also designed their own networks. And I'm sorry, let me step back. When I say design, I mean they invented their own networks. They came up with the idea of how to actually connect computers together. And because these networks were proprietary, they couldn't really play well with others, meaning these networks could not communicate. You couldn't have this device talk with this device. They were basically speaking different languages. This network over here is like, bonjour. And this network over here was like, what? No idea. Now I want to hammer this home because this is some primitive stuff. I'm talking like this is before Ethernet cables were invented. Like we're so used to Ethernet cables. We're so used to the Ethernet ports. These weren't a thing. Each of these companies had different versions of whatever they called theirs. Like, you ever try to charge your iPhone with an Android charging cable? It doesn't work. It's just not compatible. That was the networks of yesteryear, or a long time ago. Now, eventually they realized, hey, this is kind of stupid. Maybe we should all use the same networking stuff. Yeah, let's do that. Now, easier said than done. This involved meetings and committees and, I want to do this, I want to do that. You're wrong, sir. A lot of that kind of stuff. Now, there's a long and maybe interesting history, if you're into that, of how this all came about. But we eventually ended up with a networking model. A model that defines how we can connect our stuff. So that when IBM makes a computer, when Apple makes a computer, when Microsoft makes a computer, we're all putting the same technology inside that computer to make it talk to the other computers. That's why it's such a beautiful thing that a Microsoft computer can send a photo to an Apple computer. We're all using the same networking technology. We're using the same networking standards. Now, actually, honestly, we ended up with two models. One that we actually used, and then one that we still cling on to and talk about all the time. I'll show you. The model we use today is called TCP IP. This is what every computer supports and has implemented into their system. The TCP IP model, and they also call it the TCP IP stack. Now, the other model, he wanted to be the one that won so badly. People were on his side, they were campaigning, but he just did not win. TCP IP won for a variety of reasons, but it's just more widely adopted. So then why am I still talking about him if TCP IP won? I'll show you. It's weird. Now again, TCP IP is just a list of rules or guidelines, standards on how computers can communicate, how we design those systems. And there's a lot that goes into that. So to make things more simple, more digestible, easier to understand and implement, we divided all those functions into layers. Layers like this right here. Each of these layers defines some kind of protocol or standard we'll use when computers connect. So for example, the physical layer, we know it's going to involve Ethernet cables. The network layer, all about IP addresses and routers. So with this standard, we all agreed we're going to use IP addresses when we communicate over the internet. Before that standard, that wasn't really the rule. You could have done anything. You could have used names from Star Wars or something. I don't know. Transport, we got TCP, UDP, port numbers. We'll talk more about that later. And then application, like, hey, when I open up my web browser and I go to netflix.com, what protocol am I going to use? Do we all agree to use the same protocol? We all agree to use the same stuff, and it's beautiful. Now we can all talk together. We can all network together. Now this is the traditional view of the TCP/IP model, the layers we see here. If you're studying for the CCNA, the 200-301, you might see the physical layer divided into two separate layers like this, which I happen to love. And if you watched my last two videos in the series, you're already familiar with the first three layers here. You've already seen them in action going through a network. We get our physical, the Ethernet cables, the network cards, the electricity flying. That's our layer 1. And then we talked about our data link layer. This is where our MAC addresses come in. Our layer 2 addresses. How hosts on the same network can communicate. And the switch uses those layer 2 addresses, those MAC addresses, to know where to send information. And then of course we have our layer 3, our network layer. We know this to be IP addresses. We know that we assign our devices IP addresses, and this is how they communicate. This is how the router can know where to find people and route those packets to the right people. And then we have our other layers, and we will talk about those, but not right now. We'll get to it. Okay, now, what about the OSI model? Where does this guy come in? Well, let me show you. Similar to TCP/IP, he works on layers. In fact, he shares the same layers as the TCP/IP model. He just has a few extra. So physical data link and network transport, yeah, let's talk. That's the same. But then at the application layer, it's a bit different. We're going to add a couple more. We're going to add a session layer and a presentation layer. Let me scoot this guy up a bit. There we go. Now, as you're studying networking, as a network engineer, the main difference between the TCP/IP model and the OSI model are these two extra layers. Now, the concept of these layers, what they bring to the table, do not go away with the TCP/IP model. I'm saying it too much. All that happened is we stuffed those two layers inside the application layer. But Chuck, you still haven't told us why we're talking about the OSI model. Why are we even talking about it? This is why. I told you these two models were at war with each other. Who was going to win? And during those wars, it was widely believed that the OSI model was going to be the one that was adopted, which, by the way, stands for Open Systems Interconnect. And because it was thought to be the clear winner, we started using the layers that the OSI model has as our day-to-day terminology. And even when TCP/IP was the clear winner and it killed and murdered OSI, we still refer to the OSI layers when we describe network functions. Now again, not a huge deal because layer 1, 2, 3, and 4 are the stinking same as the TCP/IP model, as long as you're referring to the Cisco version of it right now. But when you get up to the layer 5, layer 6, and layer 7, clearly we got a little disconnect there. But when network engineers talk about it, OSI always wins. We will always refer to the application layer as layer 7. This right here is layer 7, and there's only 5 layers here. That's just how we do it. It's how we roll. But I will say this. If you're trying to learn networking, if you're studying for the CCNA, you need to know both of these models. And there's a fun way to memorize this. So the OSI model, 7 layers, harder to memorize. We'll use a mnemonic device. So application, presentation, session, transport, network, data link, physical. Let's try all people seem to need data processing. I'm sure there are better ones. That's just how I learned it. Let me know below if you have a better one. I can't tell you how many times throughout my career I've referred to that phrase, that mnemonic device, to remember the 7 layers. And then what about reverse? What if you're not going from application to physical? What if you're going from physical to application? Which can happen routinely, right? I got one for that too. Please do not throw sausage pizza away. Makes me hungry every time. Now again, a big reason to remember and memorize the OSI model is A, you need to know it for any exam you might be studying for, and B, it's honestly the thing we reference the most when network engineers are troubleshooting or working through any kind of networking issue. Oh, that's a layer 7 issue, application. Hands off, not my problem. Or hey, that's a layer 1, layer 2, layer 3, or layer 4 issue. Okay, time to see what you learned. Get your coffee ready, your thinking cap on. Let's do this. Exam questions right now. Question number 1. Which of the following operates primarily at layer 2 of the OSI model? Select the best answer. And go. If you said the answer was switch, you're absolutely right. If I hit show answer, fingers crossed, yes, I'm right. The switch operates at the data link layer, layer 2 of the OSI model. Router? Nuh-uh. Where's the router operate at? Layer 3, IP addresses, the network layer. The hub? That might have been a little bit confusing for you because we compared switches and hubs in one of our earlier videos in the series. Where do they operate? Remember, hubs are stupid. They got no smarts. They don't operate at layer 2. They're not even aware of MAC addresses. All they do is just repeat electrical signals when they receive them. Out all ports. So they are primarily physical. And quiz, what layer is physical? Layer 1, right? And then a WAP, a wireless access point. This was kind of a tricky one because they do operate at layer 2. They also operate at layer 1. So they're not primarily focused on layer 2. So if you put that answer, you're half right. You're kind of right. But we're looking for what primarily operates at layer 2. And that, of course, is a switch. Question number 2. Which of the following devices operate primarily at the physical layer of the OSI model? Select 2 choices. Now, we kind of already covered this. Let's see what you got. Go. Okay, here we go. Here are the answers. A, repeaters, and C, hubs. Let's see if I got it right. Boom. Now, this may have been a bit tricky for you because we haven't talked about bridges, and that's fine. But through the process of elimination, we know that, hey, switches, those are layer 2, and we just talked about that. Routers, layer 3, of course. We just said that hubs are physical, and I even mentioned that hubs will repeat electrical signals when they receive the electrical signals over the wire, and repeaters do the same thing. Bridges, on the other hand, are similar to switches in that they do deal with layer 2. But guys, that's about it. If you like this video, hit that like button. If you have any comments or questions or need help with your CCNA, comment below. Or you can jump into my Discord server. Ton of guys in there, ton of gals in there helping people out. Now, if you want to see more of this, more stuff like this, go check out thisisit.io. It's a membership that David Bombal and I run. Go check it out. It's pretty cool. And also, in just a few hours, I'm launching episode 4 of this series, where I dive deeper into the OSI model and the TCP/IP model, and we'll actually watch a packet go through a network and we'll analyze each layer as we hit it. So be looking for that. It already might be out, actually, so check it out. Well, anyways, episode 3, that's a wrap. I'll catch you guys later.